good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future in Reverse. Okay, so in the previous class, we have discussed about the image formed by a plane mirror, the difference between virtual and real image, etc. All these things have been discussed, and also we have discussed about the laws of reflection, what is reflection, and the terminologies related to reflection. In today's class, we are going to discuss about the images formed by a pair of mirror. So images formed by a pair of mirrors. Okay, so make that write down the topic: images formed by pair of mirrors. So there are two mirrors present. Okay, so in this case, what will be the number of images formed? How will be the images formed? These things are to be discussed in today's class. Okay, so in case of when you are thinking of a pair of mirror, the mirror, first of all you need to understand how the mirrors are inclined. That is the first thing that needs to be understand, how the mirrors are inclined. Okay, so there will be certain angle theta by which the mirrors are inclined. Fine. So we have to first of all consider that angle for which at which the mirrors are kept. Then we have to also consider whether the object is placed symmetrically in between the two mirrors or asymmetrically in between the two mirrors. Okay, so these are the things that you have to keep in mind. Now, before going into details, just let me talk of some practical example. I think many of you have went to salon, barber shop. Okay, in the salon, you have seen that there are two mirrors, one in front of you and another at the back of you, and those mirrors are basically parallel to each other. They are something like this, isn't it? Something like this. So why these two mirrors are kept? And if you have seen that you cannot see the back side of your hair in the front mirror. For that, what happens? The image of your back side is formed at the back mirror, and the image in that back mirror, it acts like an object for the mirror at the front side of you, and you are able to see the back side of your head in the front mirror by seeing the image from the mirror behind present you. Okay, so in this way you can easily see the back side of yourself. Now if you have noted carefully or observed carefully, there are not only two images formed, there are many images formed, and it looks like there is an image within an image within an image within an image, and like this it keeps on continuing. So it seems as if there are multiple images formed within another. Okay, so how these effects come? Okay, basically this when two mirrors are kept parallel to each other, the reflection goes on taking place, and as a result you can see many images formed within the mirror. Okay, fine. Okay, so now let us come to the this is the practical application that you can actually observe in your daily life. Now let us come to the mathematical formulas that can give you the number of images formed when such a pair of mirrors are kept. They may be kept either parallel to each other, perpendicular to each other, or at any other angle. Okay, so first of all let us consider that the angle between the two mirrors. Okay, the angle between two mirrors is theta. Between two mirrors, let us consider that angle to be theta. Okay, fine. Now we will calculate one number which is given as n equals to 360 by theta. So calculate one number, n is equals to 360 by theta. Okay, 360 by theta. Fine. Now depending on the value of this n, whether it is an odd number or even number, there will be two cases. Suppose think of the first case, that when n is basically odd. Okay, so if n is odd, if the n is odd, what happens if n is odd? First let us come to the fact that when n is odd. Okay, in case of odd there are two cases. One will be when the object is kept asymmetrically, and another case will be when the object is kept symmetrically. Okay, so when the object is kept asymmetrically, how many images are to be seen? Just let us know the formula. The object has been placed asymmetrically. Okay, asymmetrically. Okay, so when the object is kept asymmetrically, basically the number of images that will be formed what will be the number of images formed? The number of images formed will be basically n. Okay, so when the object is kept asymmetrically, number of images is same as that of the n. Okay, so basically it is nothing but n. This is the number of images formed when the object is placed asymmetrically. Okay, so this is the first case. Now just let me lower the camera a little bit down. Okay, now I think you are able to see it. Yeah, okay, fine. Now when the object is kept symmetrically, the n comes out to be odd number and the object has been kept symmetrically. In that case, what will be the number of images formed? In that case, number of images formed will be basically n minus 1. So number of images formed will be equal to n minus 1. Okay, n minus 1. So I think the numerical formula is clear, and the second part of the formula says that when n is even, so when n is even, in case of even, if the n turns out to be even, it need not to be seen that whether the object has been kept symmetrically or asymmetrically. In both the cases, it will be the number of images will be the same. So if it is even, now in case of even, what happens in case of even? So it may be for both symmetrical and asymmetrical case. Okay, for both symmetrical and asymmetrical case, both the cases the same thing turns out. Okay, asymmetrical and symmetrical case. Okay, the same thing turns out. Symmetrical case, in both the cases, see, in both the cases the number of images formed will be basically n minus 1. In both the cases the number of images formed will be n minus 1. So if we get the even number, if n is an even number, okay, then for both symmetrical and asymmetrical case the number of images will be basically n minus 1. Okay, so note down the formula. Number of images formed will be equal to basically n minus 1. Okay, so these are the formulas. So you have to remember these formulas in order to note down the number of images formed. Okay, and you can easily do some numerical problems which are given based upon these calculations. Okay, so I think the basic concept is clear. The number of images that are being formed, is it clear? Okay, fine. So now let us just see the some special cases. Okay, we will be trying to analyze those special cases through a ray diagram. Okay, so if we consider, okay, so I think we have noted down these numerical formulas. Okay, fine. You may be will some later class we will try some numerical problems. Okay, you may try on your own. Okay, fine. So we are just easing it off. Okay. Now next thing is that when two mirrors are kept parallel to each other, what happens? When two mirrors are kept parallel to each other, okay, parallel to each other. So in case of the two mirrors are kept parallel to each other, what will be the n? N will be equals to 360 degree by 0 degree. You know, parallel means 0 degree angle between then this turns out to be infinite. Okay, isn't it? So the number of images will be infinite. It may be placed symmetrically or asymmetrically, does not matter. Either n minus 1 or n, anything that you take, it turns out to be infinite. Fine. Okay. So for this, what is this? When is this case? When mirrors are kept parallel to each other. Okay, fine. So when the mirrors are kept parallel to each other, then n equals to infinite. Okay, so actually you will get infinite number of images, and that is what you see in the barber shop or in the salon. Okay, there are two mirrors kept face to face facing each other, and those two mirrors are basically parallel to each other. So you get infinite images. Now you don't get to see infinite images because the light rays, after being reflected multiple times, keeps on getting absorbed in the mirror each time the light rays are reflected. Okay, so very small amount of light gets absorbed each time the light is reflected, and as a result it will not form infinite images, but obviously it will form a large number of images. Okay, so just if we see the ray diagram, if we just see the ray diagram, so what will be the ray diagram like? See, these are the two mirrors, okay, two mirrors kept parallel to each other, and this is the horizontal ground, say below B is the horizontal ground, okay. Now in this case, if we keep an object symmetrically or asymmetrically, it does not matter. Just let us consider a point object. Here it's a point object O. If I have kept it symmetrically or asymmetrically, it may be any case, okay. So what happens? So first of all, when say if we are saying that light is first of all going and striking this mirror on the left side, okay. Now this light will be reflected, and again they will go on to hit on the right mirror, okay. And as a result, what will happen? You will be getting a image like this, okay. So one image is formed like this. Fine. Now again, when the light ray gets reflected from the right mirror, okay, on the mirror on the right side, again what happens? Again the light rays are getting reflected from the mirror on the right, okay, to the mirror on the left, okay. So in this case again something like this happens. It goes on like this and it goes on like this, okay. Now again, if we just plot this back, trace back this reflected rays, it will go on and meet at a point. So here we get another image, okay. So this is the, say this is the first image I1, this is the second image I2, and this keeps on going, okay. But it will not be for infinite, as I've said. The light rays keep on getting absorbed each time it is being reflected, okay. So after a certain time you will see definitely a large number of images, but it will not be infinite, okay. So this is the case with when the mirrors are kept parallel to each other, okay, fine. Now what happens when these two mirrors are kept perpendicular to each other? Okay. So just let us see when theta is perpendicular, means theta is 90 degree, okay. So I am erasing it off, okay. So if theta is 90 degree, fine. So we will be just, when mirrors are kept perpendicular to each other, and here the angle will be 90 degree. This will be not infinite, something else. So when mirrors are kept perpendicular to each other, so n will be equals to 360 by 90, and that turns out to be 4. So n is 4. So it's an even number. So even number, as you know, the number of images found will be n minus 1. So number of images will be basically n minus 1, okay, equals to n minus 1, 4 minus 1, that is equals to 3. Fine, 3. So in case of two mirrors are kept perpendicular to each other, you will be getting 3 images. Let us see how, okay. So if we consider two mirrors kept perpendicular to each other like this, okay, they are kept perpendicular to each other like this, okay, fine. Now just we are doing the silvering on the back side, okay, silvering on the back side, fine. Now an object can be placed symmetrically or asymmetrically, it does not matter, because for when the n turns out to be even, it is all the same for both the things, okay. So if I just consider, okay, a object to be here at this point, okay, at this point, fine, it's an object O, okay. So if I consider the reflection is first on the mirror, which is in the vertical plane, okay, vertically which is kept. So if I just consider two light rays like this, one goes here, okay, one goes here, and the other goes here, fine, other goes here, okay. So after reflection, what happens? This will be going like this, and this will be going like this, something, okay. And if we just trace back, okay, okay, you will be getting two images, okay, you will be getting two images, fine. So if we just trace back this, and you will be getting something like this, okay, fine. So in this way, first image is found, okay. This first image, what happens? This first image is actually acting as the object for the second mirror, okay. This image I1 is acting as the object for the second mirror. Again, the light rays are also getting reflected from the second mirror, isn't it? The light rays are also getting reflected from the second mirror. So if you just take out this light rays like this, it is just going out like this, okay. It is just going out like this. So it will be again reflected like this, okay. And if you just take them, it will be something the image. Okay, I am not able to draw it accurately because there is a shortage of space, but the image will be something like this. Okay, so you are not able to see, just let me take down the camera a little bit downwards. Okay, fine. Here it will be the image. So here it will be the second image. I2 will be found here. Okay, second image I2 will be found here. Fine, I2. Now the first image I1 acts as the object for the second mirror, and the I2 also acts as the object for the first mirror. Okay, so in this case what happens actually, when the light rays will be reflected, there will be another image formed. Okay, if we just consider that the light ray first falls on the horizontal mirror, then definitely here we will also be getting a, say the light rays from here directly falls on this surface, and it falls on the surface here. So just take the reflected ray, okay, and you consider another light ray falling here and just getting bounced back like this. So just draw the mirror. So you get another image here, I3. Okay, so see, three images are being found here. So first the light is reflected in this direction, then in this direction, then in this direction. Okay, fine. And this light ray comes and falls and goes back in like this way, and this light ray falls and goes back like this way. Okay, okay, so there are three images formed. So it is, you can easily understand that if we keep two mirrors perpendicular to each other, there will be three images formed. Okay, so with that today we will end our class here. I hope the ray diagrams are clear. If you draw this with scale perfectly, images will be coming. Okay, so please try and practice these diagrams at your home with a scale and pencil. Okay, okay, fine. So I think the concept is clear. So with that we are going to end our video here. In the next class we will be basically discussing about the next topic, that is the spherical mirror. Okay, so with that we are ending our class here. Please do study well, and if you have any query, please mention into the comment section. We will be happy to solve your problem. Okay, so thank you, goodbye.